Welcome to Indirect Proof and Inequalities in One Triangle. Today's objective is to apply the triangle inequality theorem. Let's look at a map and let's look at three cities and try to determine the length of the distances between the three cities. So the three cities we're focused on here are San Antonio, Austin, and Mason. So the map shows the approximate distances from San Antonio to Mason and from San Antonio to Austin. What is the range of distances from Mason to Austin? So from here we know that from San Antonio to Austin is about 78 miles, and from Mason to San Antonio is 111 miles. So our question is, what are the possible values from Mason to Austin? And the triangle inequality theorem is going to help us to solve that problem. So let's introduce the triangle inequality theorem and see how it applies to these two examples. So the triangle inequality theorem states that the sum of two side lengths have to be greater than the third side for it to be a triangle. So, for you to have a triangle, the sum of two side lengths has to be greater than the third. So once again, for you to have a triangle, the sum of two side lengths has to be greater than the third. So let's look at these two examples. So example A is a triangle because 4 plus 4 equals 8, which is greater than the third side, 7. Also, 4 plus 7 is 11, which is greater than the other side length, 4. So this one is a triangle. Let's look at example B. So for this one, let's add these two. So we have 3 plus 3 equals 6. Now 6 is not greater than 7, therefore this is not a triangle. Once again, the triangle inequality theorem tells us that the sum of two side lengths has to be greater than the third. For example A, it worked because 4 plus 4 was greater than 7 and 7 plus 4 was greater than 4. But for B, it did not work because 6 is not greater than 7. Let's look at three more examples of the triangle inequality theorem, and let's tell whether a triangle can have sides with the given lengths. So, for example A, we have 3, 5, and 7, so let's add up the first two. 3 plus 5, and that's 8, which is greater than 7, so that works. And if we add up the next two, 5 plus 7 equals 12, which is greater than 3, so that works. And then we'll add up 3 and 7, which is equal to 10, which is greater than 5, so that works. So example A, that is a triangle. For B, let's add up these three side lengths. We have 4 plus 6.5, which is equal to 10.5. Now 10.5 is less than 11, so this, for example B, this is not a triangle. And I don't even have to bother with doing the other sums because this one didn't work. Now for example C, our three side lengths are n plus 5, n squared, and 2n, when n equals 3. So this one requires us to do some substitution first. So I'm going to substitute the value of 3 into each of these side lengths. So my actual side lengths will be 8, 3 squared is 9, and 2 times 3 is 6. So now I have my three side lengths. Now I can apply the triangle inequality theorem. So I'll do my first sum. 8 plus 9 equals 17, which is greater than 6. So that one's good. Then I have 9 plus 6 equals 15, and that is greater than 8. And then I have 8 plus 6 is equal to 14, which is greater than 9. So this one is a triangle. Let's examine the relationships between the angles and sides of a triangle. Now here I have a 90-degree angle. Let's say that this angle is about 60 degrees. And let's say this angle is 30 degrees. Now I'll leave my side lengths to be unknown. So I'll say that this is side A. I'll say this is side B. And we'll say this is side C. So what we want to examine is which side is the longest. Now, just visually, we can see that B seems to be the longest. But why is that? Well, if you think about it, the 90-degree angle is the biggest angle. So this side has to be the biggest side. So in a triangle, the larger angle is opposite the longer side. So the larger angle is opposite the longer side. Now, let's flip the question. Which side is the shortest? Well, that makes sense. If we look at all the angles, the smallest angle would be 30. So the smallest side would be C. So, in a triangle, the shorter side is opposite the smallest angle. And that's the relationship between the angles and sides of a triangle. Okay, let's look at two examples of triangles, and let's work on the ordering of the sides and the lengths. For the first example, we want to write the angles in order from smallest to largest. So to do that, we want to do is we want to examine the side lengths. So here we have side length GH, HJ, and GJ. Now the smallest here would be GJ, 27.2. So what I want to do is say, okay, which angle is opposite of that? It's angle H. So angle H has to be the smallest. So here's the first angle. Now let's look at the next biggest side, which is 28.5. 28.5 is opposite of angle J. So angle J is the second smallest. And finally, that leaves us with angle G, which is the biggest, which makes sense because it's opposite of side 33.4. So here are the three angles in order from smallest to largest. Okay, for the second example, let's write the sides in order from shortest to longest. So the first thing we have to do is figure out what this angle is. Now we know from the triangle inequality theorem that the opposite of this biggest angle is going to be the biggest side. But we have to add up these three angles to figure out what the third one is. We know in total is 180 degrees in a triangle. So we're going to do 180 minus 39, which is 141. And then we're going to subtract 54, which is 87. So this angle right here is 87 degrees, which is good to know because that's going to be our biggest angle. So our smallest angle here is 39. So the shortest side is km. Next one would be 54, which is opposite of LM. And for the last one, the opposite side is LK. So we just looked at the triangle inequality theorem of one triangle. Now let's look at inequalities in two triangles. So let's first start off with image A. Now in image A, let's say that segment AC and segment DF both equaled 15. And let's say that segment AB and segment DE equaled 10. Now, if I know this about both of these triangles, but I don't know what the measures of these angles are, I know that the measure of A will be greater than the measure of D if side length BC is greater than side length EF. So, for example, let's say I knew that BC equaled 20 and EF equaled, let's say, 17. Since this third side is bigger than this third side, then I could say that angle A is greater than D. This right here is called the hinge theorem. The hinge theorem says if two sides of one triangle are congruent to two sides of another triangle and the included angles are not congruent, then the longer third side is across from the larger included angle. This pictured below demonstrates the converse of the hinge theorem. So for this theorem, if we know, for example, that HG is greater than KL, and we know that this side length and these side lengths are congruent, and these ones as well, then we can conclude that angle J has to be greater than angle M. So it's basically taking the idea of the relationships of the opposite sides of angles and sides to determine which ones are going to be bigger. So for the hinge theorem, we focus on the side lengths first, and then we make a conclusion about the angles. And for the converse of the hinge theorem, we focus on the sides first, and then make a conclusion about the angles. So let's look at the inequalities in triangles. For this first example, I want to compare the measure of angle PQS and the measure of RQS. So let's just highlight those on our diagram so we can see which angles we're referring to. So PQS is right about here, and I'm going to draw it in because I'm not saying they're congruent. I just want to highlight them. So here's PQS, and RQS is this angle right here. So what we want to do is simply look at the opposite sides. If we do that, we can see that PS is bigger than SR. So if PS is bigger than SR, then angle PQS has to be greater than angle RQS. And that's all we want to determine here. We want to look at the opposite side lengths and determine which angle is bigger. Now we can only do that if these two angles are congruent, these two sides are congruent, and this side is congruent. So that's how we compare them. Okay, for the second problem, we want to find the range of values for z. So let's see if we can make our first two statements about congruency. So let's see if we can use the hinge theorem. Well, we know that UV is congruent to VW, so there's one side. And then we know that TV is congruent to itself. So once I show that two sides are congruent, I can use the hinge theorem. Now, this side is smaller than this side. So since TU is less than TW, I know that the opposite angle, or we can call it angle UVT, that has to be less than this angle right here, which is TVW. So now I have quantities for these two angles, so I can just plug those quantities in. Now angle UVT is 6z minus 3, and TVW is 45 degrees. So I solve for z. I have 6z is less than 48. Therefore, z has to be less than 8. So this is the first inequality, but we also have to think about the fact that this angle is in a triangle. So no matter what, 6z minus 3 also has to be greater than 0, because you can't have an angle measurement that's less than 0. So 6z minus 3 has to be greater than 0. And if I do that inequality out, I have z is greater than 0.5. Which makes sense because z can't be 0. If z was 0, and I plug that in right here, I would have an angle that was negative 3 degrees. And that can't work out. So you have to do the second inequality as well. And that's the end of our video for today. Take care.